Hello, this is Dr. Hassan Abdullah, and I'm here with the course Introduction to Natural Language Processing. The topic is in front of you, and the supplemental website is www.easymcq.com/goget. So, this course consists of quite a few topics, and right now we are in the topic of word embeddings. And there is the supplemental website which I just mentioned. That supplemental website consists of many powerful tools, a collection of tools and features. And if you view these videos, so these videos cover those tools and features which will facilitate your understanding and comprehension of this wonderful course. Now we move on to that website. So you can see that there are quite a few courses here, cutting edge courses. In addition to natural language processing, we have machine learning, artificial intelligence, core computer science courses. So let's move on to the course of our interest, which is natural language processing. And then we move on to the topic of our interest, which is word embeddings. Topic 4. So this topic consists of, as you can see, 22 questions and answers. So what is word embedding and what are their characteristics? So word embedding, basically we are looking for a representation of the words, a numeric representation, because our programs work on these numerics, all our arithmetics, statistics, and calculations. So we are looking at a dense representation because earlier we looked at a very sparse representation, which is one hot encoding. So there are many zeros and there is only a single one. So we are looking at a dense representation, which is having less zeros. As a matter of fact, no zeros are preferred. And there has to be semantic similarity. It's not based upon the frequency distribution, but upon the meaning of the words. So if we have a representation of two words, and if the words are similar, then that representation is similar based upon their meanings, and there are contextual relationships between those words which are highlighted. Where, for example, king minus man plus woman is a queen. So this kind of operations can be performed. Of course, these operations cannot be performed on plain English. So this is for you to understand. So how are the word embeddings created and what are their benefits? So we have an approach which is called as the word to vector approach, and we convert the words based upon their characteristics into a vector, and that vector is multidimensional. And then we have this GloVe approach, and we have other approaches also. So I'll briefly go over them, and of course when the time comes we'll spend more time on these approaches. So what are the benefits of these word embeddings? Capture the semantic similarity. So that is very important because when we know the relationship between the words, then we can perform good, say for example, speech generation or text generation or machine translation, and we can make, and the machine can make kind of a sense out of it. And the contextual meaning representation, of course the meaning of a word based upon the context in which that word is used. For example, bank and bank as a financial, as the river bank, bark as a dog bark versus the skin of a tree, and so on. And that improves the performance of the NLP task tremendously because then the semantics and meanings are there. Dimensionality reduction, because when we have the one hot encoding and here see like 10,000 vocabulary size, then we end up with a tremendously large one-dimensional vector for each word, which is 10,000 size. Tremendous wastage of space because all are zeros except one. So with the word embedding, that is reduced tremendously. And transfer learning means that whatever has been developed for a domain, that can be applied to another domain, and of course it may require certain customization. Handling synonyms and variations, because the words have shades of meaning, and because of that similarity context, those shades are captured in those word representation. And of course, handling out of vocabulary words. It may so happen that there are words which are not there in the system, in the vocabulary. So based upon the context and the similarity, a meaning can be deducted for those words. For example, out of words, n-gram with helps in dealing with rare or puppy is placed close to dog in the feature space, and king and queen are placed together. And of course, the based upon the contextual meaning of the surrounding words. And of course, when this dimension, the dimensionality is reduced, it reduces the space complexity, the space required, and the computational resource requirement is also tremendously reduced. So what are the major applications of word embedding? Some of them I have already mentioned. Sentiment analysis, because when we know this representation of a word and other words, and we know the sentiment associated with the words, so matching those words based upon their similarity, that helps the system identify the similarity of the unseen or the unmatched words. Machine translation I've already mentioned. Named entity recognition. There's a complete topic on named entity recognition. Basically, what it does is that what is the association? For example, if I Apple, with a capital A, is that a company name or is this a fruit, right? So, and if in a text, this is a difficult example. It can be simpler or difficult. For example, in a statement, so this place is the name, or this name is the name of a person, right? Because there are maybe, for example, buildings and roads and say counties which are named after a person. So when we are referring to that county, say for example, then that is a person or that is a name. And text classification, semantic association with scam related content. So we were getting spam, and in that spam, what might be scam? So based upon these the semantic similarities, the scam is labeled as spam. And word similarity and semantic search. So basically, for example, restaurants and eateries, based upon their spelling, and they are very different. But based upon that word embedding and that's the similarity associated with them, the machine can infer that basically what eatery means, even though it's not exactly used in the query. So, and of course, if you are interested, there's more material, lots of material you can check for the from the references. So, what is a word? What is a document? What is a sense? And what is the context? And then, of course, is how what is the relationship between them? So, let's go one by one. So, basically, word is smallest unit of meaning in language. A word is the smallest unit, and of course, that is not that simple because that smallest unit of meaning has a lot of meaning, and of course, those meanings go across sentences, and documents consist of sentences. So, sense is specific meaning given in a context. The meaning of a word goes as per the context. For example, I deposited money in the bank, so of course I'm not talking of a river. The board is at the river bank. So of course that river bank, we know, or the machine will know that what is meant by the word bank used over here. And in the context, the word contextualized word embeddings, which is this, that's the right word. So the word bark would mean that the sound bark makes by a dog, or it is the skin of a tree, right? So tree's bark was rough. So this is the sense, the meaning associated with it, and this is what in this context what the meaning. And a document is collection of words and sentence structured in a particular way to convey information or meaning. So the document may be a legal document, it could be a financial document, it could be maybe an architectural plan or a software engineering document. So the words, their meanings, and then the sentences constitute a document. And the objective is to be able to understand that document. So it could be a web page, it could be news articles. So financial topics will be interpreted the word bank as a financial institution. So the meaning of a word depends upon the context in which is used. And of course, if there is a hurricane, then of course the boat can be referred in the context of a bank, and that bank could be a river bank, or it could be a financial bank or financial institution. So see that it's not that trivial. So if you're interested, there are more references. You click over here. And then what is the relationship between word, document, sense, and the context? So the first question was what they are, and now the question is what is the relationship between them? So this what this picture tells that a man is known by the company that man keeps, right? So these are strange men, so they have strange company. So a word is known by the company it keeps. This is a famous quotation by some smart person. So words and context, words acquire meaning from the context they appear, right? So apple with the lowercase versus apple with the uppercase. Words and sense. The sense a word makes on in a given sentence depends upon in its context. That we have been saying repeatedly. For example, light can mean not heavy or light can mean illumination also, depending upon the surrounding words. Document in context. So if there's a document about fruit and vegetables, then we know that when we see apple, even in if the a is in uppercase by mistake, we know that is most likely it is referring to a fruit, not a product or a company. So document word sense and in NLP, right, used in text classification, summarization, in many applications, question answering. So this is the example. We have the bank and what the bank could mean in the context, and it's a place or body for financial operations. So see, and of course, if you are interested, you can read more. So now we move on to the next set of Q&A. So we move on to the next set of questions and answers. So what are the fundamentals of NLP with reference to text and meanings? So now we go into more deep. So one is the word sense disambiguation. So disambiguation means that removing the ambiguity, disambiguation. So for example, the bank is closed. So we know what is bank, okay? either a financial institution or it could be the river bank, but how to make the machine knows. Maybe it's a river and the river is clogged or blocked from one side or whatever. So that is what word sense disambiguation. Then is the contextual understanding. The bank is closed. Does it means that that financial institution is no longer operating? So the first one was a disambiguation, other is in the context, or maybe it is closed for the day. So that's another option. And the river bank is obstructed, which could be linked with the previous one also. Then is the syntax and structure. The bank is closed, the word bank is the subject and closed is the predicate. So that is the syntax and structure. And then is the named entity recognition. So what we are referring to, what it really is. So when we say the bank of XYZ is closed, so named entity recognition help that bank of XYZ is an organization, right? So the bank of XYZ is an organization does not mean that the bank belongs to XYZ. It could, but in this case, we know that this Bank of XYZ is name of an organization. It is not belonging to XYZ. Then is the lexical semantics. What does it means? Individual words and their relationships to each other is crucial, right? So when we say the bank is closed to have a particular semantic meaning in the context. Okay, so it will become clear in pragmatic. The bank is closed, uttered as a response to someone asking about the business hours, or in case the financial institution is not open. So if it's a Sunday, then the meaning of what the bank is closed is different from if it's a Monday or any other working day. So we see that it's not so straightforward even for humans. So what it would be very difficult for machines. Co-reference resolution, right? So if we say that the bank is closed, it opens tomorrow. So it means the bank. It means the bank. It opens tomorrow. And of course, that bank, we are making it simple, keeping it simple that the bank is the financial institution. Of course, if you're interested in reading more about it, you can click on the references. So what is meant by word meaning? So there are different meanings of words, denotative meanings, connotative meanings, literal meanings, and so on. And we as a humans, many times we know what meaning we are referring to, but the challenge is making the machines understand. So first of all, we need to understand the complexity of the problem itself. So we have this denotative meaning. This is the simple one. When we say a dog, it denotes a domesticated carnivorous mammal. And when we say a tree, it means that we have a plant, elongated stem. A tree is different from, say, a bush or a flowering plant. A tree is different. And supporting branches and leaves. There are many plants which may consist of a single stem. Okay, may not have branches such as certain flowers. So this is denotative. We know the literal or the primary meaning. Then is the connotative meaning. Connotative means what it in additional meaning. These meanings influenced by personal experience, cultural context, social norms, and there is a feeling associated with them. So when we say a home, it evokes feelings of warmth. When we say house, the feelings are different. The word snake might have negative connotations, right? And of course the colors also, which is like a complex topic. Then are the literal meanings, the meanings which are in the dictionary. When we say that the person kick the bucket in certain cultures means the person died. But in the dictionary, right, there is no such word as kick the bucket, which means a person dies. And of course, if we say a rose denotes a flowering plant. That is the denotative meaning. Connotative meaning is it symbolizes love and romance. Literal meaning of the cat is on the mat is straightforward. And figurative meaning, he is the lion in the battlefield. Right now, this doesn't have to be in the dictionary. Okay, so this is non-literal meaning. So basically, lion does not literally refer to the animal, but the bravery and strength and courage. So, with all due respect to Mr. William Shakespeare, this statement is of course is true for humans, but how about the machines? So that's the challenge of NLP, making the machines understand that what the rose is. And of course, if you're interested, there's a lot of material to read. All right. So, what are the connotative meaning of the green apple? So, the green apple refers to freshness. It refers to youth. It refers to tartness because it is not may not be so sweet, and it refers to health and nutrition. So you see that all these explanations are there for a green apple, and we humans have not a lot of knowledge. Based upon that knowledge, we can infer, we can understand that which of these we are basically referring to. So freshness. Likely green frequently include nature and growth, okay, and health and nutrition, uh, include association with health, nutrition, and wellness. So it is the point I'm trying to make. It is not so simple, even for us. So making the machines understand it is even a bigger challenge. So how to represent? So before the machines can understand, we should be able to represent the meanings of the words for the machines. Okay, and then we look at the resources and the limitations also. So one is the one hot encoding, which we have mentioned a number of times. It's a binary vector. So the binary vector for apple would look like this. Okay, banana would look like this, and so on. So where the banana would be represented as the one because the apple would have a one here and all the zeros. So this is not very smart because it does not capture the semantic similarity. Semantic is the meaning. Then we have the distributional model such as the vector space model, which we have mentioned and discussed. So that vector for apple would have similar meanings depending upon the dimensionality, similar to banana itself, which is also a fruit. And of course, if it was carrot, then we would not like to consider carrot as a fruit or tomato. So they'll have a different vector representation. Then we have the Word2Vec, a skipgram that was by gentleman Mikolov. Okay, and the words king and queen will have similar embeddings because they appear similar in the similar context. Then is this global representation. So the fact that king is related to queen not only through their local but also globally, also global co-occurrence. This is more powerful. Then these are the contextualized word embeddings, surrounding words offering dynamic representation of the word depending upon its usage in a sentence, because the speech and the text, the things or the words may not be static throughout. They may be changing. So we need contextualized embeddings. And then we have Bert using the transformers. Okay, I went to the bank to deposit money. The word bank will have different representation compared to I went to the bank to fish. We cover Bert and transformers in more details, or you can go to the main page and in the yellow box type Bert and you can get a lot of responses. Then is the sense-based representations, dictionary-based representation approaches. Okay, if you use WordNet, the bank has multiple meanings in multiple sentences. So, and of course, then is the graph-based representation. So we have this cat. The cat is a mammal and has fur, and a mammal is an animal, right? And of course, a cat likes cream, and Tom is a cat, and I'm referring to Tom and Jerry. So you see that this is another representation of the meanings. So there are quite a few representations. Then, of course, which I have not mentioned due to space constraints, is the knowledge-based representation. So these representations are used for the machine, and then there are certain limitations of these representations also. For example, WordNet is not covered in a lot of details in this course. I used to cover it in prior courses which I have taught, but things have changed a lot over the period of time. So there are certain limitations of WordNet. For example, it has limited coverage, and it is especially for new and domain specific terms. So it is limited. Static structure may not adequately capture the dynamic nature of language, where word meanings and relations evolve over time. It is static. And of course, it is ambiguity and polysemy. Multiple meanings are not very well catered for. Subjectivity, because it is done by humans, maintained by humans, so different people have their own understanding and their background and cultures. And fine-grained semantic information, lack finer-grained semantic such as entailment, causality, temporal relationships, the relationships which are based upon time. Difficulty in handling new concepts, okay, emerging concept, neologisms. What is this? Just go to the main page and in the yellow box type, all right. And language dependency is primarily for English, and it is limited for other languages. And the maintenance and the update to bring it with the changes, that is not very frequent. So with this, I end this part A of word embeddings, and then we'll start with part B of word embeddings.